We're going to be doing Physics 062541 May June paper 2021 today. Let's start. Question number 1 says a skydiver of mass 76 kg is falling vertically in still air. At time t equals 0, the skydiver opens his parachute. Figure 1.1 is the speed time graph for skydiver from t equals 0. Part A says use figure 1.1 to determine the deceleration of the skydiver immediately after the parachute is opened. So in the question it says that at t equals 0 the parachute is open, and there are two main points which you should note in order to do this question, which is that the gradient of the speed time graph gives us acceleration or deceleration, and the formula for gradient is y2 minus y1 divided by x2 minus x1. Now we are going to be drawing a straight line on the graph and finding two coordinates, two x coordinates and two y coordinates for this. And here is our straight line. We can take 2 points from here, one this and this. Our y1 will be 40, x1 will be 0.5, y2 will be, note that this is not touching 60, so it's 58, and x2 is 0. Now we use our formula here and find our answer. y2, which is 58 minus 40, divided by x2, which is 0.5 minus 0. We put this in our calculator and we get 58 minus 40 divided by 0.5 minus 0. The answer is 36. And don't forget to add your units, meters per second square, for acceleration or deceleration. The second part says the force due to air resistance acting on the skydiver immediately after the parachute is open. So we are given with the deceleration and we have the mass, which is given in the first part. 76 kg. We're given with the mass, which is 76 kg, and acceleration or deceleration, which is 36 meters per second square. The only formula which links this is F equals ma. So we have to use F equals ma. We know the mass, which is 76 kg, and acceleration, which is 36. So the force will be 2736 Newton. Don't forget to write the units. Part B says explain in terms of forces acting on the skydiver his motion between t equals 0 and t equals 6. At t equals 0, they said that the skydiver opens the parachute. As soon as the skydiver opens the parachute, the velocity starts decreasing. So we can write that here. The velocity starts decreasing. As time increases, the resultant force upwards decreases until the weight and the upward force is equal. Part C. Explain why opening the parachute cannot reduce the speed of the skydiver to zero. So, the final position of the skydiver will be when the upward force is equal to the downward force, right? But the weight is still acting on the skydiver and gravity will pull him down. So, we can write here when the parachute is opened, the weight is acting downwards while the forces are balanced. The forces are balanced. Next question. Figure 2.1 shows a wooden trolley of mass 1.2 kg at rest on the rough surface of a bench. A ball of mass 0.52 grams. Make sure to convert this into kilograms. Travels horizontally towards the trolley. The ball emends itself in the wood of the trolley. The trolley moves with an initial speed of 0.65 meters per second. Calculate the impulse exerted on the trolley. The formula for impulse is mass into velocity. We are given with the mass and we have the velocity as well. So the mass of the trolley is 1.2 kg and the velocity is this 1.2 into 0.065. We can put this in our calculator and 6.5. We'll get our answer as 0.078. And don't forget to add the units. So we have 0.078 kilograms meters per second. The second part says the speed of the ball as it hits the trolley. We just calculated impulse in the first part. So we know the impulse is 0.078. The formula is impulse equals mass into velocity. We are given with the mass of the ball here, which we have to convert into kilograms. And we need to find the velocity, which is speed. So we can rearrange this formula. V equals I by M, which is just going to be 0.78 divided by this in kilograms. 0.52 divided by 1000, which is going to give us 5.2 into 10 raised to power minus 4. And we put this in our calculator to find our velocity. And our new velocity is 150. And don't forget to add the units. Meters per second. As the trolley moves across the rough surface, it slows down and stops. Explain in terms of work done the energy change that takes place as the trolley slows down. So we can see here what will happen. Now, the final position of the final velocity of the trolley will be 0. So work is done by the trolley. Okay, so work is done by the trolley. The kinetic energy is decreased and is converted into frictional energy. And as it is converted into frictional energy, thermal energy is also produced. So we can write that down. As the trolley moves across the rough surface, work is done by the trolley. The kinetic energy is converted into frictional energy. Converted into frictional energy. And some energy is lost through thermal energy. We're done with this. Question number 3. Explain in terms of molecules why liquids are difficult to compress. Now we can see here I've given a picture on the side, right side here. We can see the molecules are closer in liquid, right? So the force of attraction will be more. So we can write down that in our answer. As the molecules are closer, the force of attraction will be more. That's why it's difficult to compress liquids. Part B says figure 3.1 shows a device that uses liquid pressure to lift heavy boxes. And the diagram is here. So we can see the diagram. The pump moves the oil here and the oil applies the force upwards. Okay. The boxes are lifted up by pumping oil into the cylinder. The force upwards on the piston due to the oil and the force downwards on the piston due to the air above the piston combine to produce a constant force of 8,800 Newton. The pressure of air is 1.0 into 10 raised to power 5 Pascal. And the cross-sectional area of the bottom of the surface is this. So we are given with force, which is 8,800 Newton. We are given with pressure. Pressure of air is 1.0 into 10 raised to power 5 Pascal. And the cross-sectional area is 0.016 meters square. It says calculate the pressure of the oil at the bottom of the surface of the piston. So we have the formula pressure equals force divided by area. We are given with the force, which is 8,800 Newton, and area which is given 0.016. So we can put this in our calculator, which will give us 550,000. Now they're asking the pressure of the oil at the bottom of the surface. So we have to add the air pressure and this pressure to get our total pressure. Okay, so pressure of air plus pressure calculated, which is for the oil, which will be 550,000 plus the air pressure given, which is 1.0 into 10 raised to power 5 Pascal. So we can add here 1.0 into 10 raised to the power 5, which will give us our answer as 6.5 into 10 raised to the power 5, which is same as this. Next part says that as the boxes are lifted, the depth of the oil increases. Okay, this is very important. You should note this down. Explain why the pump must exert an increasing pressure on the oil as the depth of the oil increases. So here is the diagram. You can see here that when the level increases, the pressure of the liquid will also increase, right? Pressure of the liquid will also increase. In order to oppose that effect, the pump must exert an increasing pressure. So we can write that down. As the depth increases, the pressure increases in the liquid. Therefore, to oppose the increase in pressure, the pump must exert an increasing pressure. An increasing pressure. Third part says suggest one reason why the force of 8,800 Newton in B cannot lift boxes of weight 8,800 Newton. Well, the easiest answer for this is the upward force balances the downward force, therefore there will be no motion. The upward force balances the downward force, therefore there will be no motion. Question number 4. An aluminum saucepan with a plastic handle contains cold water. Figure 4.1 shows the saucepan on a hot plate. Part A says that state why the pan is made from aluminum but the handle is made from plastic. The reason why it is made of plastic is because the plastic is poor conductor of heat. So we can write that down. Plastic is poor conductor of heat. When you're boiling something or if stove is turned on, What will happen if this is not plastic and made of aluminum? The heat will transfer into the handle, and when you hold it, you'll get burned. So that's why the handle is made of plastic, so that you don't get burned. Part B. The hot plate is switched on and the temperature of the water increases. The internal energy of the water also increases, right? State in terms of molecule what is meant by an increase in internal energy. When there is an increase in internal energy, there will be increase in kinetic energy of the molecule. There will be increase in kinetic energy of the molecules. Part 2 says that explain in terms of the atomic lattice and electrons how thermal energy is transferred to aluminum. So we can say that atoms near the pan move and gain kinetic energy. Pan, oh, it's opposite. Atoms near the pan gain kinetic energy and move. The atoms pass energy to the other atoms. Then the atoms pass energy to the electron and the electron move around the lattice. Part 3 says eventually the water reaches boiling point. Thermal energy from the hot plate is still being transferred to the water. Explain in terms of molecule the effect of thermal energy on the water. It says the water reaches boiling point. What happens when the water reaches boiling point? Imagine if we have this pan, there's water in this. When it's on boiling point, there will be no temperature change. That means the energy is used for something else. What is the energy used for? The energy is used for breaking the bonds. So we can write that down. Water molecules will gain energy and break bonds between the molecules. Then the molecules will escape as water vapor. Therefore, they have gained potential energy. Therefore, they gain potential energy. Part 4. The mass of the water decreases by 0.11 kilograms in 300 seconds. The specific latent heat of vaporization of water is given by this. Calculate the rate at which the water gains thermal energy. First, we are going to be noting down what is given in this question, which is mass 0.11 kg. Time is given, which is 300 seconds, and latent heat, specific latent heat of vaporization is given. So 2.3 into 10 raised to power 6 joules per kg. We know the formula Q equals ml, where Q is P into T. We're given with P, we're given with T, M, and L. So we can use this formula and find out our P. So we can rearrange our formula. We get P equals ml by T, where ml is 0.11 into 2.3 into 10 raised to power 6 divided by 300 seconds, which will give us our P. We'll plug this in calculator and we'll get 0.11 into 2.3 into 10 raised to power 6 divided by 300, which is 843. 843, and don't forget the units, which is W. Question number 5. Figure 5.1 shows the structure of liquid in glass thermometer. The bulb of the thermometer is placed into a beaker of warm water. As the liquid expands, it moves along the tube. Explain in terms of molecule why liquid expands when heated. So we can write here molecules gain kinetic energy. Molecules gain kinetic energy. Therefore, the liquid expands. Part B. Explain in terms of molecules why liquid expands more than solid when heated. So I have given a diagram on the side. You can see the difference between the molecules. The molecules in liquid are little further apart, and in solid they are stuck to each other. So as we know, when the distance decreases between the molecules, the force increases. So we can write here force between molecules is less in liquid as compared to solid. Hence, less energy is required to separate the molecules. Molecules. Part C says a second thermometer has a large bulb that contains more of the same liquid than the thermometer, shown in figure 5.1. It has a different scale. In every other way, it's identical. Okay, explain how the sensitivity of the second thermometer compares with the sensitivity of the thermometer in figure 5.1. We can draw the bulb size here. When this is heated, the liquid will expand more because the area is more as compared to this bulb. Okay, this is 5.1 figure 5.1 bulb, and this is the new thermometer's bulb. So we can see when this is heated, the liquid will expand. That's why the sensitivity of the second thermometer is high. We can write down that here when the liquid inside the bulb is heated, the liquid in the scale will move faster. Therefore, the second thermometer has more sensitivity. Part 2 says explain how the range of the second thermometer compares with the range of the thermometer in figure 5.1. We can see that when the liquid is heated, okay, if we apply same amount of heat on this bulb and this bulb, the liquid in this bulb will increase more than the smaller bulb. That's why the range for the bigger bulb will be less. We can write down for our answer the range for second bulb will be less as small temperature will expand. We can write change in temperature. Change in temperature will expand the liquid more. Okay. Part D says state one everyday problem that is a result of thermal expansion. So there are many examples. One of the examples are buckles of the bridge on hot weather. Buckles of bridge on hot weather. Suggest and explain one way of solving the problems. On the right side, I have given a picture. We can add this gap in between the bridge so that when it expands, the bridge does not get damaged. So we can write here add gaps in between the bridge. So when the bridge expands, the gap closes. Question number 6. Figure 6.1 is a full-scale diagram that represents a sound wave traveling through air. A part says on figure 6.1 mark 2 points each at the center of different compression. Label both the points C. So we can see here that this is compression and this is compression. And we label it as C. The B part says the speed of the sound is 330 meters per second. Measure the diagram and determine the frequency of the sound. You have to find the distance between these both points, which is 0.051 from my scale. And now we use the formula V equals F lambda and we find frequency. We're given with V, which is 330 meters per second, and divide it by our measurement, which is 0.051. We put this in our calculator. which will give us 6470, which is approximately equal to 6500. And don't forget the units, which is hertz. Part C says the wave reaches a barrier. Figure 6.2 shows the wave passing through a gap in the barrier. Okay, so the frequency of the wave is increased to a value many times greater than the value obtained in B. Okay, describe and explain two ways in which a diagram representing the wave with the greater frequency differs from 6.2. We can see here this is the same diagram which was given in the previous part. We can see that the compression on the left side is more than the compression on the right side. You can write that here, more compression and the wave is spreading on the right side. So we can say spreading out on the right side. We can see that the wave is spreading here, right? That's what we write for the second part. Question number 7. Figure 7.1 represents an alternating current generator. Direction of the rotation. A student rotates the handle H as shown in figure 7.1. On axis 7.2 sketch on figure 7.2 sketch a graph to show how electromotive force between terminals X and Y varies with time during two complete revolutions of the coil. So we can see here they have given us Y and X, and we take time on X axis and EMF on Y axis. And as you know, the graph for alternating current generator is sinusoidal graph, and we know that electromotive force is the highest when the plates are parallel to the field line, because at that time they're going to be cutting all the field lines, right? You can see this coil. This coil is parallel to the field lines. At this point, all the field lines are cut and the EMF is the highest. So we have to draw a sinusoidal graph. The initial position of the coil is horizontal. So the graph will start from 1. 1, and it says you have to show for 2 completions. So we have to draw around 2 wavelengths, 2 waves. So we can take this half and then we can take this half and this half. The graph will go like this, down, and then it's gonna go up again, and then it's gonna go down and go up again. Make sure this distance is equal. As I'm drawing on this, it might not be equal. So in exam, make sure that the amplitude is equal for all of them. The student turns the handle more quickly. State 2 ways in which EMF between terminals X and Y changes. As you increase the number of turns, the EMF will increase. So the amplitude, which means EMF will increase. The amplitude will increase. which also means that the EMF will increase. And as we know, when the time decreases, the frequency increases. What is the frequency formula? 1 by t. As the time will decrease, the time period for one wave will decrease, the frequency will automatically increase. So we can write frequency will increase. Part B, terminals X and Y are connected to primary coil of a transformer. State and explain what happens in the transformer as the student turns the handle of AC generator. When the student turns the handle of the AC generator, there is a field line here, magnetic field line, for both the coils, secondary and the primary coil. Now, when the student starts turning the handle, a field line will be created. And eventually, the field line will go and interfere with the secondary coil, and it will cut the field lines of secondary coil. And as you know, when the field lines are cut, EMF is induced. So we can write down here alternating current is there in primary coil. As the student turns the handle, the field lines produced by primary coil will cut the field lines of secondary coil. Hence, EMF is induced in secondary coil. Part C says, explain why power losses in transmission cable are lower when the electrical energy is transmitted at higher voltage. We can take our equation V equals IR, and we know that I is directly proportional to V, inversely proportional to V. And as we know, R will remain same because resistance of the wire doesn't change. We are not changing the cable. So the resistance remains the same. So resistance remains the same. Therefore, energy loss will be less. Question number 8. Student sets up a circuit that includes a 12 voltage of battery and 800 ohms of resistor, a voltmeter and a thermistor. Figure 8.1 is an incomplete circuit because the symbol of the thermistor is missing. So we have to draw the thermistor. And we know the thermistor is drawn like this, and there's a tick in between. Part A complete by drawing the symbol of a thermistor between P and Q. B part. The 12-volt battery consists of 8 identical cells connected in series. Calculate the electromotive force of each cell. So electromotive force will be 12 voltage divided by 8 because 8 identical cells are connected in series, which will be 1.5 voltage. Part C says the reading on the voltmeter is 8.0 volts. Determine the resistance of the thermistor. First we can use V equals IR. The reading on the voltmeter is 8 voltage, so we can write 8 here, and I equals, we don't know I and we don't know R. We can find out I from the previous part of the question. We are given that, so this is 8 voltage and total we have is 12 voltage. So 12 minus 8 will give us 4, which is for this resistor. So we can find out our I with this, which will be V equals IR. We have 4 and I we have 800. So 4 divided by 800, which will give us I, and we can plug in our I value here, which will give us our answer as 8.0 divided by 4 by 800, 1600. Don't forget to add the unit. Part 2 says a few hours later the student notices the reading on the voltmeter is greater. Explain what can be deduced from this observation. We know that resistance of thermistor increases as the temperature decreases, and we know that V is directly proportional to R. So that means if the resistance increases, the voltage also increases. So resistance of thermistor increases, and we know that the temperature decreases because this is the condition for thermistor, that as the temperature decreases the thermistor resistance increases. So we can say temperature decreases. And last we can say that the voltage across resistor 800 ohmic resistor will be less. We're done with this. Question number 9. There are 3 naturally occurring isotopes of hydrogen: hydrogen 1, hydrogen 2, and hydrogen 3. The nuclide notation for hydrogen 1 is 1, 1, and H. Write down the symbol using nuclide notation for hydrogen 2 and hydrogen 3. So this is pretty easy. You can write 2, 1, and H, 2, 3, 1, and H. In a fusion reactor, a nucleus of hydrogen 2 and a nucleus of hydrogen 3 undergo fusion. What is meant by fusion? The definition of the fusion is, nuclear fusion is, it is a process where smaller nuclei join together to produce a bigger nucleus. Part 2 says fusion reaction produces a free electron and one other particle. Write down using nuclide notation the equation that represents this reaction. So we know the reaction takes place between hydrogen 2 and hydrogen 3. This is given in this part of the question. Now they say that a free neutron and one other particle is released. So this will become 1 0 for neutron plus one other particle. We can see 3 plus 1, which will be 5, 5 minus 1 4, and 2 plus 1 plus 1 equals 2, which will be 2, and this represents alpha or helium. We can write alpha or helium, anything we can write. Nuclear fission in the sun is source of most but not all the resources that are used to generate electricity on earth. Electrical energy on earth. State two resources for which nuclear fusion in the sun is not the source. There are many examples we can write: geothermal and nuclear energy. And nuclear energy. That's it. We are done with the question paper. Hope you understood everything. If you have any question, write down in the comment section. I'll try to respond as soon as possible. Give this video a thumbs up, like, share, and subscribe. See you in the next video.